I'm Allie.
Hi, I'm Ryan.
And this is our project, Neuromuscular Junction. But before I explain this process, I'm going to point you to this key down below. First, we have calcium that is gray, acetylcholine that is red, sodium that is white, potassium that is orange, and then down below we have three different channels. We have the voltage-gated calcium channel, the voltage-gated sodium channel, and we have the acetylcholine receptor site. Now I'm going to explain the process of neuromuscular junction. An action potential reaches the axon terminal, and a chemical referred to as neurotransmitter is released. During the neurotransmitter, calcium rushes in, and the vesicles reach the synaptic cleft, as you can see down below at this bottom. Next, the acetylcholine reaches the receptors on the sarcolemma, causing sodium to rush in towards the muscle cell. And potassium to leave the cell. During this process, acetylcholinesterase takes acetylcholine away from the site, and this upset creates a strong electric current, forming an action potential. Now, as he's clearing the potassium, I'm going to put you down back to the key so I can show you the components for the muscle contraction. We have this blue triangular shaped bead, which is ATP. We have this pipe cleaner mixture, which is troponin, tropomyosin complex. We have two pom-poms here, the myosin head and the actin filament.
Now I'm going to explain the process of muscle contraction. Sodium ions flood down the T-tubule and forces calcium out of the sarcoplasmic reticulum. Calcium then attaches to the troponin tropomyosin complex, and the actin myofilament binding site is revealed and causes the cross bridges. The myosin then forms a cross bridge to the actin. ATP binds to the myosin heads and causes the cross bridge to detach. This results in the myosin heads to be in the cocked position with ADP plus a phosphate. This result is a muscle contraction using hydrolysis.
During the relaxation of the muscle, calcium is reabsorbed by the SR, which is right here. And the cross bridges detach and active sites are covered. Then the muscle returns to its relaxed state.
And during the process of repolarization, the ions will go back to their original state. Now I'm going to explain the process of rigor-mortis. Rigor-mortis is caused by the lack of ATP in the body and causes calcium to stay on the troponin tropomyosin complex in a contracted state. This causes myosin heads to stay attached to the actin myofilament. In order for the calcium to travel back to the SR, it needs ATP to go from a low to high concentration. After 12 to 24 hours, depending upon the temperature of the room, the proteins begin to break down and cause the muscle to become relaxed. This concludes the process of rigor-mortis.